The Keplerian telescope is used to observe distant objects by refracting the image through a series of lenses. You should have been able to assemble one in the video with the refracting telescope demo. After assembling it, you may have noticed that the image through the telescope is upside down. We can add a relay lens to the telescope in order to flip the image upright. A relay lens is a lens used to correct the orientation of an image through a system. They are also used to relay an image over a long distance and are common in optical devices such as telescopes, periscopes, and endoscopes. When building the Keplerian telescope, you should have placed the two lenses so that the distance between them equaled the sum of their focal lengths. When adding in a relay lens, the focal points of the two lenses should be placed at the object and image distances of the relay lens. Typically, we could calculate the distance of the image based on the distance of the object, but to make this process easier, we can use a concept called 2F2F imaging, which allows us to know where both the image and object distances will be if we place both at a distance equal to 2 focal lengths away from the relay lens. The materials needed for this are 2 paper towel rolls, scissors, tape, a ruler, 3 6.8 cm focal length lenses, and pieces of paper. Since we know the relay lens needs to be placed 2 focal lengths away from the focal points of the other 2 lenses, we can figure out where each lens needs to be put in the paper towel rolls by placing them 3 focal lengths away from each other. In our case, since the focal length of each lens is 6.8 centimeters, we can place a lens in the tube every 20.4 centimeters. Using the ruler and paper, mark every 20.4 centimeters, then line up the paper towel rolls with the paper and mark where the lenses will go. Use the scissors to cut a slot on the markings, being sure not to cut all the way through the tube. Insert the lenses into the slots and tape them down. Tape the paper towel rolls together and observe the upright image.
Applications of relay lenses. Relay lenses are generally used for two reasons: image inversion and image transmission across a distance. Inversion is something that can be done by various optical instruments such as prisms, mirrors, or other lenses. Image transmission can be done by other optical instruments, however, it is simple to do it with a relay lens without altering the image quality too much. The first significant use of this idea was in endoscopes. Endoscopes are long tubular medical devices used to image difficult to reach portions of the human body. And how do they connect to relay lenses? In the 60s, we didn't have the cameras of today that could convert the image into digital data in a small, reasonable size. The cameras back then that did this were bulky, and it would have been difficult to insert such a camera into the human body. A solution to this was to use a set of relay lenses that were small and allowed the operator to view the damaged tissue in the patient's body. A technical overview of relay lenses. In our experiment, we placed the lens at the 2f distance. This simplifies the creation of our modified Keplerian telescope, inverts the image, and keeps the magnification equal to 1. However, a downside is that this makes the system larger than may be required. Take, for example, phone cameras or the cameras in defense systems. Based on the requirements of the system being made, the relay lens can be placed at a different distance, thereby changing the magnification and the overall size of the system.